So here's another question that we wanted to cover for the group. How does your water jet compare to a laser, to a plasma, to an EDM? So we wanted to just touch on that really quickly. We'll run through a few slides. Okay, so let's compare the 4 different processes. So this is just a snapshot of the same shape, obviously cut by the 4 different processes. On the top left is the water jet. We'll look at that in more detail. On the top right, you can kind of see the laser edge. Just visually, you see a little bit of heat affected zone there. On an EDM on the bottom right, obviously very high tolerance, high accurate wire cut part. And on the bottom left, you see by far the most heat affected area, probably potentially the fastest cut here, but maybe not the most accurate cut of the 4 processes. So there's really these 4 major process improvements that you can kind of experience from water jet. So cutting into material, we've talked about. Cold cutting process, so we're not introducing heat or stress to whatever's being cut. A very satin smooth edge. It's rare, or not often do you see a secondary finish required to the water jet cut edge. I'm talking about the actual finished edge quality. And then minimal kerf allows you to cut very intricate parts, but it also can greatly reduce material cost if you're cutting high expensive alloys or composite materials where you want to maximize your sheet utilization there. So here's the quick close-up of the water jet part.
A zoomed in photo of this is a stainless steel part cut on one of our water jets. So you don't get those heat affected zones or that hardening of the edge to it. And again, as a result, we get a generally considered really smooth finish, which is going to range from that 80 to 125 RA finish on that. Again, you can dictate that, go to a faster edge quality with our parts and our software, but typically you see a very smooth finish on a part. And for most operations, you typically don't need some sort of cleanup or secondary operation on that, where you get a finished part coming right off the water jet that you could use in your fabrication.
Can you cut hard and soft materials on the same water jet? It's a really good question. Yeah. And the answer is absolutely yes. There's some things you got to do to protect the surface of the materials or the bottom of the materials, or to keep things as dry as possible. But the answer is absolutely yes, you can cut abrasive jet and water jet on the same machines often.
If you're cutting mild steel and then jumping to an aluminum or even a carbon fiber, is there any tooling changing that's required for that? And with our setup for our water jets is all you need to do is just simply in our software select what is the material type and thickness. So you don't have to change the flow rates of garnet, the pressure of the jet or the pump. That's all controlled right at our operator station.
So to kind of summarize this question about comparing water jet to these other processes, we typically think of those other processes as complementary, honestly. They're really not a competitive process as much as a complementary process. Some of the most efficient shops that we've ever seen obviously have multiple processes that are really good at individual things. The cool thing about a water jet is it's kind of good at all of them. It can be a very good entry into a lot of other markets to help you explore other business opportunities.
I think one of the big benefits for a lot of people in the fabrication world is although there are some great technologies with lasers, EDMs, and high-def plasmas, those are very focused kind of machine tools where they are very good at a select kind of bandwidth of materials or products that they might be cutting. Whereas a water jet, we're good at everything in some ways, where it can, no matter what you put underneath that cutting head, we'd be able to cut it and process your parts. Yeah. The question regarding stacking material. This is very unique to water jet technology as well, but the answer is yes, you can stack it with a water jet. So you can not only put multiple layers of the same material, you can also put different materials and cut it all at the same time. And good picture there in the background kind of showcasing just that kind of stacking several layers thick of a material in process.
And you often see this in like sheet metal applications where you're cutting high volume of the same geometry out of a thin gauge material. It makes all the sense in the world to stack that up to get more efficiency out of it.